Hey Math 2, we're looking at simplifying radicals. Should be a little bit of a review. Today's going to take the easy side. Tomorrow we'll get in some cubes and some variables. But for right now, I just remind you what a radical is. Okay, a radical is this symbol. Okay, that's the symbol we use. And to fill in this blank, an integer squared will give us a perfect square. We recreate our perfect squares by recreating this list here. And then, of course, what I want you to do is to write that perfect square list right there. Now, I already skipped one by accident right here. There's supposed to be a 16. And there you go, I fixed it. All right, so just to pay attention to that. So again, here's some vocabulary for us. Radical sign. The inside of a radical we call the radicand. And then the outside we call the index. Now the index tells us what root we're taking. All right, whether it's a second root, a third root, a fourth root. In other words, a square root or a cube root, etc. A couple examples over here. The 5 and the 6 are both radicands. Okay. The index on the 6 is a 3, which means we're going to take the third root, also known as the cube root. And then here's the one that gets us. All right. If there is no index, if it doesn't look like there's a number there, we assume that it's an invisible 2. And the reason we assume it's invisible 2 is because we've always in the past called this symbol a square root sign. It's only recently that we started calling it a radical. So square root, squares are second power, so this is going to be a second root. All right, I'm going to show you two different methods for simplifying. All right, you can use a prime factorization or you can do perfect squares. So when we do prime factorizations, we're going to write down all of the prime factors of the radicand and then circle which ones are in pairs. So I used a little factor tree right here. Here's a little factor tree, prime factorization of 12, 3 times 2 times 2. And notice that 2 is a pair. Okay? So that pair becomes my answer. Okay, so when the pairs themselves become the coefficient in front and the unused prime number becomes the radicand. All right? Try again. This time I use a factor tree to break down the 18. I've got 2 times 3 times 3. And I have a pair of 3s. So the pair of 3s becomes the outside, and the inside becomes that 2 that's left over. All right. Now, my other method would be using what we call perfect squares. So we wrote down all those perfect squares earlier on the top of the page. So what I'm looking for now is I'm looking for what perfect square will go into 12. Okay, so I look on that list, and of course it's 4. 4 is a perfect square. 4 times 3 will give me 12. So I like that because the square root of 4 is 2. And then I can write 2 square root 3. And if you look, that's the same answer we had over here. So I jumped the gun a little bit there, but 18, what's the perfect square that goes into 18? Well, it's going to be 9 and 2. 9 times 2. Now 2 is not perfect, but 9 is. 9 was the perfect square. So the square root of 9 is 3. So it's 3 square root 2. All right. I'm going to run through these first ones using the prime factorization method. I'm not going to talk through it, just going to let you watch. Recommend that you I'll slow this down a little bit, but I recommend you just hit pause when you need to. Okay, on that last one right there, notice that the pair of 2s became the outside, and because I had more than one thing left over on the inside, I went ahead and multiplied them back together, so that was a 2 times 5 became the 10 on the inside. So that was all my method 1. I'm going to do the second column in method 2 only. Now notice right here on 32, 4 times 8 does give you 32, but guess what? 8's not finished, because remember back here on number 6? So
Derek Chester, please come to the office. Derek Chester, please come to the office.
That's one of the
Thank you.
disadvantages of method 2, is sometimes if you don't choose the largest perfect factor, you have to do it more than once. The fastest way of doing 32 would have been using 16. All right, if you got any questions, bring them to class. Love to help you.